Hey guys, so right now you should have watched the video of the guy who took the cone and took to fill the cylinder. So after you watch that, I want you to take out your notes of 5.3b. If you have not watched the video, it's right above this one on the daily schedule. So go ahead and open up the video and watch it, okay? So I'm assuming everyone's watched it, and now what I want you guys to realize, which you probably should have already saw, is what we are going to figure out is volume of a cone. So as a quick reminder, what is a cone? Cone's like an ice cream cone. It's kind of like a pyramid except it has a circle on the bottom. And I hope you realize that when we took 3 cones, that equaled the volume of 1 cylinder. That's going to help us find the volume of a cone very shortly. So it says, draw a cylinder and a cone that have the same height and congruent bases. Predict how many volumes of a cone compares to the volume of a cylinder. Well, we kind of already showed you that, and we saw that 3 cones equals 1 cylinder. Okay, so how many cones of water is needed to fill up the cylinder? 3. What fraction of the cylinder is filled by the volume of the cone? So 1/3 of the cylinder equaled 1 cone. Now it's really important because on the next one what we're going to see is manipulate the equation of the cylinder to show the volume of a cone. So really quickly, we know that the cone, 3 cones equals 1 cylinder. We know the formula of a cylinder is pi r squared times the height is equal to 3 cones. Therefore, if I want to figure out what 1 cone is, all I would do is divide by 3, and I would get the formula of a cone is equal to pi r squared times the height all over 3, or the same exact thing, just written with the fraction in front, pi r squared times the height times 1/3. Now I want you guys to realize that all of this that I'm highlighting in yellow is just the formula for a cylinder. The only difference for volume of a cylinder and volume of a cone is that volume of a cone is multiplying by 1/3 or dividing by 3. It's the same thing. But I just want you to realize that I'm highlighting in blue. This is the only difference between the area of, the volume of a cone and volume of a cylinder. So explain in your words, your own words, how the volume of a cone compares to volume of a cylinder. We're going to skip this one because we already talked about it. So it's just 1/3 of a cone, 1/3 of a cylinder equals 1 cone. So now what we are going to do is we're going to use this formula. So the only thing now is we need to figure out how can I figure out the height of a cone. The height of a cone goes from the pointy end down to the center. And the radius is still the same. It goes from the center of the cone to the side. So remember, the volume of a cylinder is pi r squared times the height. And so to find the volume of a cone, all I do is have 1/3. Now I believe the direction said it wants us to find the answer in terms of pi, which is the most accurate, and decimal rounded to the nearest tenth. So in the previous lesson I showed you is we're just going to leave pi all by itself and then at the very end multiply it by 1/3. So if I were to, multiply it by 3.14. So looking at this formula, I'm going to have 1/3 pi times 5 to the second power times the height, which is 8. So then now that's going to look like 1/3 pi times 25 times 8. And when I continue to multiply these two, I'm going to have 1/3 times 200 pi. So then when I multiply these one more time, I'm going to have 200 pi over 3. Now it asks for your answer in terms of pi. You cannot simplify 203 and get a perfect number, so I'm going to just leave it like this. And I'm going to get the answer of foot cubed. If you were to divide these, and I think you'd get 66 and 1/3 or 66 and 2/3, I don't know off the top of my head. You could write that, but this is the most accurate. You don't want any decimals here because that's not as accurate. So this is my answer in terms of pi. Now I'm going to do the same answer, except what I'm going to do is multiply 200 by 3.14, and then I'm going to divide that by 3. So what we're going to do is do 200. Let me write that out so you can see what I'm doing. 200 times 3.14 divided by 3. So 200 times pi, which we're using as 3.14 as our approximation for pi. And then we're going to divide that by 3 to get 209.3 repeating. And then I still use my units feet cubed. So that is my final answer right there. Now let's go ahead and look at the next one. This cone is upside down or just a different way, but same idea. This is my height. This is my radius. So the formula is, for volume of a cone, 1/3 pi r squared times the height. So let's just plug in things we know. 1/3 pi, and then r squared is 20 to the second power times my height, which is 15. It's going to be 1/3 pi times 400 times 15. So 400 times 15 is equal to 6,000 pi all over 3. I'm going to divide it by 3 now, and that does go in evenly. So in terms of pi, my answer is 2,000 pi. And we're going to use my units of centimeters cubed. This is the most exact answer that we have, but remember, I need to write my answer also into the nearest decimal, so we are going to use an approximation of pi, and as always, we're going to be using 3.14 in this class. So when I multiply this by 3.14, I am going to get 6,280 centimeters cubed. And that's your final answer. So now what we're going to do is continue on to the next one. It says a cone has a radius of 8.4 meters and a height of 5.25 meters. As always, what I like doing on these is drawing a picture when it's not provided. So I have a radius of 8.4 and a height of this cone is 5.25. So then my formula is going to look like 1/3 pi r squared times my height. It's going to be 1/3 pi parentheses 5.25 squared times the height. Oops, I plugged that in wrong. Sorry. So that's going to be 8.4 squared times my height, which is 5.25. So let's go ahead and look at that now. I'm going to have 8.4 to the second power, which is 70.56. And then I'm going to multiply that by 5.25 to give me this answer of 1/3 pi 370.44. So what I'm going to do is now divide that by 3. And I have this final answer of 123.48 pi. And what I'm going to do now is that's my final answer in terms of pi. Usually you don't want to write this as a decimal, so you could write 123 and 48 over 100, which reduces to 24 over 50, which reduces to 12 over 25. So in terms of pi, it would be 123 and 12/25 pi. I don't mind you guys leaving it as a decimal in this one. But now what we're going to do is we're going to multiply this by 3.14, which is our approximation of pi. And we're going to get the answer in terms of pi is 387.7. Now don't forget, on both of these I need my units, which is meters. So it's going to be meters cubed on both of them. Also, guys, don't forget, this is my more accurate answer, but as an approximation for pi, this makes it a little easier to understand for some. Okay? All right, so now let's go ahead and look at these. It says a cone with a diameter of 9 meters and a height of 4.2. Same idea. What I want to do is draw a cone on both of these. And what I have here is I have a diameter of 9, which means I have a radius of 4.5. Next, I look at my height. The height here is 4.2. Therefore, I'm going to plug this into the equation of 1/3 pi r squared times the height. This is going to be 1/3 pi times 4.5 to the second power times 4.2. And then I'm going to have 4.5 times 4.5 is 20.25. I'm going to multiply that by 4.2. So now I'm going to have 1/3 pi of 85.05. I'm going to divide that by 3. And this will give me then 28.35 times pi. One more time. Usually they don't want you to written as a decimal in terms of pi. So this would be 28 and 35 over 100, which would be 28 and 7/20 pi. Now, you are more than welcome to have your answer look just like this in terms of pi, but now don't forget what we need to do is multiply it by 3.14. So if I take this number and multiply it by 3.14, I'm going to get 89.01. It says round to the nearest tenth, so to the nearest tenth, it would just be 89 meters cubed. And as always, don't forget to have those on both of them. So here's my answer, which is the most accurate in terms of pi. And here's my second answer that is not as accurate because there was some rounding. All right, so now let's look at this one. It says find the missing measurements for each cone described below. Round to the nearest tenth when necessary. Show all your work. So what I'm going to do, guys, is stop the video right here. I want you then to open up the second video and finish watching it from there.